Isotopes and enriched isotopes have a big role in a variety of applications. For example, in medicine, where they can be used for treatment. Isotopes can do tasks simpler, quicker, and also cheaper. Isotopes are used in many different things. For example, like smoke detectors in a house, tanks used for war, structures like jet engines, and also to control the density of mixtures such as ice cream and concrete. Now let's get started. As you may know, we are going to be talking about isotopes. In particularly, an isotope called Uranium-235. Here is the formula of uranium-235. 235 represents the atomic mass and 92 represents the atomic number. Uranium-235 has a half-life of 4,500 million years, which is the same age as Earth, so it decays very slow. So slow that no one actually knows what it decays into. Uranium-235 does undergo nuclear fission, and its equation is written right here. So it is uranium-235 plus a neutron, which will give out krypton-92, barium-141, 3 neutron energy. In this case, uranium-235 will be the parent nuclei, and krypton-92 and barium-141 are the daughter nuclei. So where does uranium-235 come from? Uranium is found close to the Earth's crust, and there is a mixture of 2 large isotopes. There is 99.3% of uranium-238 and 0.7% of uranium-235, which make up the Earth's crust. Uranium-235 can be obtained by underground mining, open pit mining, or ISR mining. So where is uranium-235 used? It was used in a bomb called Little Boy made by the US when they dropped it in Hiroshima, Japan in the Second World War. Also, marine ships use a system called naval nuclear propulsion, which use uranium-235. Variety of colored glazes use uranium-235. And also, last but not the least, wall tiles. A nuclear power plant has a nuclear reactor which uses uranium-235. In a nuclear reactor, the uranium fuel is assembled in such a way that a controlled fission chain reaction can be achieved. The heat created by splitting the uranium-235 atoms is then used to make steam, which spins a turbine to drive a generator producing electricity. The chain reaction that takes place in the nuclear reactor is controlled by rods which absorb neutron and which can withdraw to set the reactor at a required power level. The fuel elements are surrounded by a substance called a moderator to slow the speed of the emitted neutrons and thus enable the chain reaction to continue. Because uranium-235 is used as fuel, and there is a major uncorrected malfunction in a reactor, the fuel may overheat and melt, but it will not explode like a bomb. Uranium-235 is useful in nuclear reactor because under certain conditions it can be readily split, yielding a lot of energy, therefore said to be fissile. So now let's look at the pros of uranium-235. When uranium-235 goes under nuclear fission, it provides huge amount of energy, many times than any other power source that we are aware of yet. This is an economic factor, because now we do not need to buy more products to produce more energy. When it goes under nuclear fission, it is safe until something goes wrong. This is a social factor because now no one will be getting hurt. And also, no carbon dioxide or carbon monoxide production, which helps cut global warming. This is an environmental factor. So now let's look at the cons of uranium-235. A lot of leftover products are thrown from the reaction that are polluting the air. This is a environmental factor. Secondly, fuel rods are the most radioactive products in the world with the help of uranium-235. And when exposed, there isn't any escape plan for death. And this is a social factor. Thank you for listening, guys. See you guys later.